Hello everyone, myself Prajwal from Sri Venkateshwara College of Engineering. Today we are going to discuss on iSCSI, which is Internet Small Computer System Interface. This comes under Storage Area Networks. Let's see what iSCSI is. It is an IP-based protocol that establishes and manages connections between host and storage over IP. It encapsulates SCSI commands and data into a IP packet and transport them using IP/IP. It is widely adopted for connecting servers to storage because it is a relatively inexpensive and easy to implement, especially in an environment in which an FC-SAN does not exist. This is the implementation of iSCSI. It consists of a server which has iSCSI HBA. Through the IP, it gets connection to the storage array through iSCSI ports and FC ports. It also contains iSCSI gateways toward the storage array. Components of iSCSI. The host, a initiator, a target is the storage or iSCSI gateway, and an IP-based network are the key iSCSI components. If an iSCSI capable storage array is deployed, then a host with the iSCSI initiator can directly communicate with the storage array over an IP network. However, in an implementation that uses an existing FC array for iSCSI communication, an iSCSI gateway is used. These devices perform the translation of IP packets to FC frames and vice versa, thereby bridging the connectivity between the IP and FC environments. The host connectivity for iSCSI can be obtained using these three connectivity options. A standard NIC with software iSCSI initiator, a TCP offload engine, which is TOE, NIC with software iSCSI initiator, and iSCSI HBA. So first, let's see how the standard NIC with a software iSCSI initiator is. The simplest and least expensive connectivity option. It is easy to implement because most servers comes with at least one and in many cases two embedded NICs. It requires only a software initiator for iSCSI functionality because NICs provide standard IP function. Encapsulation of SCSI into IP packets and decapsulation are carried out by the host CPU. This places additional overhead on the host CPU. If a standard NIC is used in heavy input-output load situations, the host CPU might become a bottleneck. TOE NIC helps reduce this burden. A TOE NIC offloads. The next option. The TOE NIE offloads TCP management functions from the host and leaves only the iSCSI functionality to the host processor. The host passes the iSCSI information to the TOE card, and the TOE card sends the information to the destination using TCP/IP. Although this solution improves performance, the iSCSI functionality is still handled by a software initiator that requires host CPU cycles. An iSCSI HBA is capable of providing performance benefits because it offloads the entire iSCSI and TCP/IP processing from the host processor. Next, let's talk about iSCSI topologies. Two topologies of iSCSI implementation are native and bridge. Native topologies does not have FC components. The initiator may be either directly attached to the targets or connected through the IP network. Bridge topologies enables the coexistence of FC with IP by providing iSCSI to FC bridging functionality. For example, the initiator can exist in an IP environment while the storage remains in an FC environment. The native iSCSI connectivity. FC components are not required for iSCSI connectivity if an iSCSI enabled array is deployed. The array has one or more iSCSI ports configured with an IP address and is connected to the standard Ethernet switch. After an initiator is logged onto the network, it can access the available LUNs on the storage array. A single array port can serve multiple hosts or initiators as long as the array port can handle the amount of storage traffic that the hosts generate. Bridge iSCSI connectivity. A bridge iSCSI implementation includes FC components in the configuration, whereas in the native iSCSI connectivity, we do not see any FC components in the connectivity. Here, in bridge iSCSI connectivity, in this case, the array does not have an iSCSI ports. Therefore, an external device called a gateway or a multi-portal router must be used to facilitate the communication between the iSCSI host and FC storage. The gateway converts IP packets to FC frames and vice versa. The bridge devices contain both FC and Ethernet ports to facilitate the communication between the FC and IP environments. In a bridged iSCSI implementation, the iSCSI initiator is configured with the gateway's IP addresses as its target destination. On the other side, the gateway is configured as an FC initiator to the storage array. Here we can see the here in the figure we can see the FC components as well as the iSCSI gateway connected to the storage array through an IP address. Combining FC and native iSCSI connectivity. The most common topology is a combination of FC and native iSCSI. Typically, a storage array comes with both FC and iSCSI ports that enables iSCSI and FC connectivity in the same environment. It's a combination of both FC and native iSCSI connectivity. This is the iSCSI protocol stack. The iSCSI protocol stack consists of OSI model, iSCSI initiator, and iSCSI targets. Whereas the data is encapsulated with SCSI and iSCSI, TCP IP, Ethernet. The iSCSI initiator and the iSCSI target are interconnected. The SCSI and the SCSI gives the commands and data, login and discovery, windows and segments, packets and frames. These are the interconnection between the iSCSI initiator and the iSCSI target. iSCSI is the command protocol that works at the application layer of the open system interconnection, which is OSI model. The initiator and targets use SCSI commands and responses to talk to each other. The SCSI command descriptor, block, data, and status messages are encapsulated into TCP/IP and transmitted across the network between the initiator and targets. iSCSI is the session layer protocol that initiates a reliable session between devices that recognize SCSI commands and TCP/IP. The iSCSI session layer interface is responsible for handling login, authentication, target discovery, and session management. TCP is used with iSCSI at the transport layer to provide reliable transmission. TCP controls message flow, windowing, error recovery, and retransmission. It relies upon the network layer of the OSI model to provide global addressing and connectivity. The layer 2 protocols at the data link layer of this model enables node-to-node communication through a physical network. What are the advantages of iSCSI? The advantages of iSCSI are cost-effective, scalability, flexibility, long-distance connectivity, and simplicity. Cost-effective. iSCSI utilizes existing Ethernet infrastructure, eliminating the need for specialized hardware like fiber channel switches and cables. This results in lower implementation and maintenance cost. Scalability. iSCSI allows for easy expansion of storage capability by adding more storage devices or arrays to the network without the need for extensive reconfiguration. Flexibility. iSCSI supports a wide range of storage devices, including traditional hard disk drives, solid-state drives, and storage arrays from different vendors. Long-distance connectivity. iSCSI enables data transfer over long distances using wide area networks, which is useful for disaster recovery and remote data replication scenarios. Simplicity. iSCSI is based on familiar TCP/IP protocols, making it easier to manage and integrate with existing IP networks and management tools. What are the use cases for iSCSI? The use cases are server virtualization, storage area networks, backup and disaster recovery, high performance computing, cloud storage, small and medium-sized businesses. These are the use cases for iSCSI. It is widely used in virtualized environments to provide shared storage for virtual machines. It allows for efficient storage consolidation and management, enabling features like live migration of VMs between hosts. Storage area networks. iSCSI can be used to create cost-effective SANs, enabling centralized storage management and shared access to storage resources across the network. Backup and disaster recovery. iSCSI simplifies data backup and replication processes by enabling remote data transfers over IP networks, supporting off-site backup strategies and disaster recovery solutions. High performance computing. iSCSI can be utilized in high performance computing environments to provide shared access to high speed storage resources for data intensive applications and parallel computing workloads. Cloud storage. Many cloud storage providers leverage iSCSI to offer block level storage services, allowing customers to access and manage remote storage resources as if they are very well, loudly attached, or as if they were locally attached. Sorry. Small and medium-sized business. iSCSI is a popular choice for small, medium-sized businesses due to its cost effectiveness and ease of implementation, enabling them to benefit from centralized storage management and data protection without significant infrastructure investment. So this is all about the iSCSI. Thank you.